So this is your end examination question. Last year end examination is a transform question. Okay, so here you have two parts, and you have to answer only one part based on your registration number. Okay, so here we are given a system. Okay, so this is the time domain representation of the system. We have input and we have the output yn, and we have the impulse response. Okay, unit impulse response HA. Okay, so this will be time domain representation of the system. And if we go to the Z domain, okay, so here we have input in Z domain XZ, y put in Z domain YZ, and our impulse response is in Z domain, that is HZ. Okay, so if I write the expression for the output, okay, in time domain, okay, so this is in time domain. Okay, the input, the output will be Xn convolved with the unit impulse response Hn. Okay, but if you write in Z domain, okay, Z domain, this convolution will become a multiplication. That is convolution theory, convolution property. Okay, convolution property of the Z transform. This convolution will become a simple multiplication. Okay, so YZ is equal to XZ multiplied by HZ. Okay, XZ into HZ. Okay. So these are the time domain and Z domain representation for the output. Okay, so now we will move to the question. Okay, so here we are given the time domain input. Okay, so we are given the time domain input Xn. Okay, so we are given the time domain input Xn. Okay, and also we are given the Z domain output YZ. Okay, YZ, and we are asked to determine the HZ. Okay, so we are asked to determine the HZ. Okay, so so you already know that you have the idea that if we are going to do this in time domain, we have to do a convolution convolution sum. So it is somewhat difficult. Okay, so we can convert all the things into Z domain and do the work in Z domain. Okay, so it will be somewhat easy. Okay, so that means if you want to do do this in time domain, okay, you have to convert this YZ into time. No, it is not easy. Okay, it will be difficult. Okay, so we will go through our standard method. Okay, that is, we convert all the things into Z domain and we try to figure out some answer. Okay, we try to figure out the answer. Okay, so so you have YZ. Okay, so here you have YZ. And now you have given Xn, so that is in time domain. So you have to convert this to a Z domain. Then that means you have to find the XZ. Okay, so okay, so we will try to find the XZ. Okay, so that is our first step. I think you can understand why we need to find the XZ. Okay, because we are given YZ and we are asked to find the HZ. Okay, so we know that using this convolution property, HZ is equal to nothing but YZ equal to YZ by XZ. Okay, so you already have this term YZ, and if you have found this one XZ, then you can find the HZ. Okay, so that is our target. Okay, to reach that target, we have to find this XZ. Okay, now the question is how to find the XZ. Okay, okay, so we are given Xn. Okay, Xn is u minus n minus 1, u minus n minus 1 plus half n un. Okay, half n un. Okay, so this is u. Okay, this is u. So this will be half n u n. Okay, okay, so this also u minus n minus 1 plus half n un. Okay, so okay, to find the z transform for this function, you can have different approach. Okay, you can have different approach. The first approach is you can use the basic method. What is the basic method? You can try to find the total function, function, this composite function. Okay, u minus n minus 1 half n un. Okay, for that you have to draw this one first, u minus n minus 1. Then you can draw this half n un. Then you can add them together and you can find the resultant function. Okay, so that is composite signal. Okay, composite discrete signal. Okay, so this will be your composite discrete signal. Okay, okay, so you can find the composite discrete signal and then you can use that Z transform definition to find the Z transform of this function. Okay, so you can see that here this function will be minus side because this time reverse signal minus n minus 1. Okay, so this function will be like this, no? Yeah, maybe like this. Okay, so this function will be like this. Okay, there is no zero. Okay, it is starting from here at minus 1. Okay, and this you have is starting from 0, so you have half is square, half to the power 3, half to the power 4, so on up to infinity. Okay, so you can see that you have both sides. You have both sides. If you add this, okay, so you have both sides. That means non-causal signal. You will have non-causal signal. So here it has some finite value, not finite value, constant value. Okay, here your values are discrete in gradual. Okay, so this kind of function you will get. Okay, to find the Z transform of this function you can do, but mathematically it is somewhat difficult because here it is going from minus infinity to plus infinity, and there are two function actually. This side and this sides are different, so it is hard to find the power series expansion, Taylor series expansion. Okay, so I am not going to I'm not going to do that. Okay, clear why I am not going to do that? So it is somewhat difficult. Okay, if you find the composite signal and if you try to find the is a transform, it is somewhat difficult, so I will not use that method. Okay, so that method I am not going to use. Okay, instead I can use property, very simple property. What is that? Can anyone tell me what property can we use to evaluate this one and this one, composite composite discrete transform? Can anyone feedback? Can anyone feedback? What is the property? So you can, I got the answer. Yes, yes, yes. Okay, yeah, very good. Okay, so we can use linearity property first. Okay, so we can use linearity property. Linearity property. Okay, so I think now you can understand why these properties are important. Okay, so I think now you can understand why these properties are important, because we can use them to simplify our analysis. Okay, so using linearity property. Okay, so if I can evaluate this function, okay, evaluate this function, and if I can evaluate this function separately, Okay. Evaluate the Z transform of these two functions separately using the linearity property. I just can add them together. No, I just can add them together and get the resultant Z transformation. Okay, so I am not going to, so we no need to struggle to find the composite Z transform. We can easily find the Z transform of these individual terms, and then we can get the composite Z transform simply adding them. Okay, so that is the second point. Okay, okay. Now third point. Okay, so now we have to evaluate this Z transform. Okay, and we have to evaluate this Z transform. Okay, okay. To evaluate this Z transform and this is okay. I think we have already evaluated this Z transform. Okay, this kind of function we have already evaluated. Okay, to evaluate this kind of Z transform for this function. Okay, so you can use the basic method. Okay, so first you can draw the signal. Okay, if you draw the signal, you minus n minus 1, what you will get? Is it a casual or anti-casual signal? Causal or anti-causal signal? Can someone tell? Is this one is a causal or anti-causal? Causal means you have plus-sided value. Anti-causal means you have only minus-sided value. Okay. Yes, it will be anti-causal terms. Okay. It will be anti-causal signal. Okay. And how it look like? So you can see that it is first time reversed. Okay, time reversed means the normal un is in this side, so u minus n should be in this side, like this. Okay, like this, up to infinity. Okay, up to infinity, minus infinity. Okay, so here it is again time shifted by 1. Okay, so you know that in original, if you shift the time by -1, it will shift this way. Okay, this way. Now for the time reversal, we have to get this uh, image. Okay, image across this y-axis. Okay, so it will be in time when it is in time reversal. Okay, so your when this is minus, it will be shifted to this way. Okay, so this will shifted to this way. So you will start from here. Okay, so you will start from here. Okay, so this is -1, -2, -3, up to minus infinity. So this will be your value. Okay, so this will be your function. Okay, okay. Now you can use your definition. Okay, now you can use our basic definition, and then we can try to find a Taylor series expansion, power series expansion for this one. Okay, so it will be possible. Okay, it should be possible. Okay, we can find the Taylor series expansion. Okay, definitely. Actually, we have to use our common Taylor series expansion, that is 1 plus a square plus, sorry, a1 plus a square plus a to the power 3 equal 1 by 1 minus a should be less than 1. Okay, so you can use this expansion, okay, to evaluate this one. Okay, but you can see that this is in minus side, then 1 is shifted. Okay, so you can convert this to a minus side, and you can consider without the zeroth value. Okay, without zeroth value, that means without this a 1. Okay, without this one, then you can try to find the value here. Okay, okay, okay. So I think you can do this, okay, by yourself. Okay, but I am not going to use that method also, because I think you can do this by yourself. Okay, rather than using this basic definition. Okay, I try to do this also with some properties. Okay, also with some properties. Okay, so so this is my function. Okay, u minus n minus 1. Okay, so I'm not going to do the basic definition to evaluate this one. Instead, I am going to use some properties and try to find the answer for this one. Okay, so I know that we have already know that the Z transform of un. Okay, so you have already know that Z transform of un, that is 1 minus Z minus 1. Okay, so this is the Z transform of un. Okay, okay, I think this you can evaluate very easily. Okay, okay, maybe this may be in your mind also. Okay, because we have used this many times. Okay, okay, so now using this I try to evaluate this one. Using this result I try to evaluate this one directly. Okay, so can anyone tell me what are the properties should I use to evaluate this u minus n minus 1 from un? What are the properties should I use? Please feedback. What are the properties? Yeah, time shifting we have to use. Another property we have to use. What is that? Time shifting. Very good. Okay, we have to use the time shifting property. And another property we have to use. What is that one? Yes, time reversal, time shifting and time reversal you have to use. Okay. Now we will try to use this. Okay. So you can see that. Okay. So anyone, if anyone have a question, please ask. Okay. Please clear your problems at this stage. Okay. Don't take it to the future. Okay. You can clear any doubt points. Okay. Here. Okay. You can ask. Okay. Okay, so you can see that here. So you can see that it is time reversed and time shifted. Okay, time reversed and time shifted. Okay, so we have to use the time reversal and time shifting property. Okay, so you can see that you can do it. So first, if you consider first time reversal, it is okay. Then you can consider the time shifting. Okay, but you should be careful about this minus sign, because when it is time reverse, this minus will affect in different way. Okay, okay. So sometime it will be confuse us. Okay, so I will use first time shifting and then time reversal. Okay, so simply I can write this like this: minus n plus 1. Correct? Can I write this one like this? If I write, okay, if I write this u minus n minus 1, I can write it as like this: minus n plus 1. Okay, am I right? Yes, no, if you multiply this minus, you will get minus 1 minus n. So this will be okay. So now you can see that. Okay, so we normally get first we evaluate the bracket. That is our normal procedure. Okay, so first we have a time shifting. First we have a time shifting. Okay, then we have the time reversal minus time reversal. Okay, so first we can do the time shifting, and then you can do the time reversal. Okay, so I am going to do the time shifting first. Okay, so I have un. Okay, un, the Z transform of un is 1 1 minus Z minus 1. So what is the Z transform of un plus 1? What is that? And here the Z is greater than 1. Okay, and what is here? What is un plus 1? Can you remember the time shifting property? I will show you the property. This is our property table, no? Okay. So this is the time shifting property. So you can see that this is the time shifting property. Okay. So what it say? So if you have x n minus k, you will have z minus k x z. Okay. So you have to simply multiply the x z by z minus k. Okay. So what have I do? Okay. So here k. So here you can see that it is n minus k. Okay. So here k is okay. So in minus k you have z minus k x z. Okay. So if I have u n plus 1, so this is k. So k will be minus 1. Okay. So here minus k, so it will be z minus minus 1. So it will be z1, no? Correct? Z1 xz. Okay, xz means this. Okay, correct. So I will get u n plus 1 is equal to, so this is u. Okay, this is u n plus 1 will be z divided by 1 minus z minus 1. Are you okay with this? Do you have any problem related with this? Okay, thank you. So I think it is clear for everyone, no? How to come to this stage. We have used time shifting property. Okay. So here minus k. If it is minus k, it will be minus k. So here it is plus 1. So it will be plus 1. Okay. So z minus 1 minus z minus 1. So this will be our, so this is not equal. Okay. So this will be our z transform. Okay. un plus 1 z transform will be z minus z1. Okay. So what is the ROC for this? What is the ROC? Region of convergence. Okay. So here it is given. Okay. So the ROC will be xz. Okay. The xz will be the ROC. But if k is greater than 0, okay. If k is greater than 0, the infinity will not be there. Okay. Infinity will not be there. And if k is less than 0, okay, z is equal to 0 will be not there. Oh, no, sorry, the other side. Okay, if k is greater than 0, z is equal to 0 is not there. If k is less than 0, z is equal to infinity is not there. So, so in our case, k is equal greater than 0 or k is less than 0. Can you tell me, someone? So in our case, so here, okay, so in this case, okay, so k is greater than 0 or k is less than 0? K is less than 0. Yes, because, yeah. So k is minus 1, no? Yeah, k is minus 1. K is equal to minus 1. Okay, so k is less than 0. Okay, so k less than 0 means you will not have the infinity. Okay, so you will not have the infinity, no? Let's see it again. So k is less than 0, z will not have the infinity. Okay, now you can see that. Okay, so I will write it. I will, I will write it here again. Okay, so you have un. Okay, z transform of un will be 1 minus z minus 1. Don't worry about this one. If you can't remember this, it is okay. Okay, it's okay. If you can't remember this, that is okay. Now, I think you can evaluate this very easy. Okay, but you should be able to evaluate this. Okay, you no need to keep remember this. Okay, but you have to evaluate this. Okay, if I want you to use the time, the set transform properties, sometime in the question paper, this will be given. Okay, as data. Okay, so you no need to remember this. Okay, but if I ask you to evaluate this, you should be able to evaluate this. Okay, 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 okay. So so the z transform will be so the ROC will be z is greater than 1. Okay, so here if have the unit circle. Okay, okay, so ROC will be here. Okay, including infinity. Okay, so for this one, the infinity is in the ROC. Okay, so this is in the ROC. You can see that. Okay, so it is beyond this unit circle. Okay, because this is the magnitude of z is equal to 1. That is this unit circle. Okay, so your ROC will be greater than this unit circle. So your ROC will be the outside of this unit circle. So infinity is there. Okay, okay, for this one, the infinity is in ROC. Okay. But when I get un plus 1, okay, I get z 1 minus z minus 1. Okay, but here the ROC will be z is greater than 1, the same ROC, but z is equal to infinity is not there. Okay, so this is the z transform and this is the ROC. Are you clear? Okay, so here this is statement I get from the definition. Okay, from the property definition. Okay, actually I think we understand this, how this happened using the unit step function. I have explained this, how this happened when this k is greater than 1 or greater than 0 or greater than less than 0, how this z will be changed, how this z is changing, we have already illustrated using unit impulse function. Okay, so I think you have the idea how this happened. Okay, if you can't remember, please go through that lecture and try to refresh your mind. Okay, try to refresh your memory. Okay, so are you clear up to here? So I hope you are clear. So if you have any problem, you can ask. Okay, okay, now we will move to the next property, time reversal property. Okay, so if I time reverse this, that means if I reverse this n plus 1, so what will be my output? Okay, what will be my output? So you can remember the time shifting, time reversal property. Okay, so this will be the time reversal property. Okay, so what it means? Okay, so okay, so it means that if it is time reversed, this z also will be reversed, time reversed, not reversed. In z domain, it will be reversed. Okay, so if it is x minus n, so it will be z minus, not, it is not reversed. Okay, it is minus 1. The power will be changed, minus 1. Okay, so z will be changed to z minus 1. Okay, it is not reversed. the Z will be changed to Z minus 1. So if I reverse this, okay, so you can see that if X minus N, okay, if you have X minus N, okay, X minus N, you will have X Z minus 1. So all Z will be replaced with Z minus 1. Okay. So here also all Z will be replaced by Z minus 1. So it will be Z minus 1, 1 minus Z minus 1. So here minus 1 will be reversed, no? Minus 1. Okay. So I will have Z minus 1, 1 minus Z. Okay. Okay. So this I have. So if I divide this by Z minus 1, Z minus 1, Z minus 1, okay. So I will have, okay, and not divided. If I get out the Z minus 1 here, okay, Z, I will have 1 Z 1 minus Z, no? So this will I have, and I will have Z minus Z square, correct? So this will be my Z transform, correct? Am I right? I didn't do any mistake, no? So here you have to do the minus, okay? So this will be minus, Z minus N will be minus, and 1 by, so this Z minus 1 also will be minus 1, okay? So it will be become Z, okay? So you have this, okay? So you will have this one here, okay? Correct? I hope it is correct, okay? So here, the how the ROC will be changed. How the ROC will be changed? It is changed in 1 by 1, no? 1 by range, okay? So here, in this line, ROC will be changed, okay? So if the Z, okay, it will be changed 1 by R1, 1 by R1, okay? So this will be your 1 by R2. This will be your ROC, okay? Okay, so it will be 1 by, the ROC will be 1 by, okay? So here you have Z greater than 1, okay? Okay, so this will be your ROC, and also Z is not equal to infinity, okay? So if you, so this is your ROC for this one, time shifted one, N plus 1, okay? The original one. And how to find the time shifted one, time reversed one, okay? So this will be 1 over region, no? Okay, 1 over region. So this will be Z less than 1 and Z is equal to 0, correct? Are you okay with this? I just get the 1 by region, okay? 1 by 1 by ROC. I just get the 1 over ROC, correct? Is this okay? Still you didn't get it. Okay. So, okay. So you can see that, okay. So what is this? Okay. So I get this property, okay. So I get this property, okay. So, so this will be my property, okay. This will be, I will get this over, okay. Okay, so now we are going to use this time shift, time reversal property, this one. Okay, so it is stated that if you have xn, if you have xn sequence, time domain sequence, and if you convert it to z domain, it will be xz. Okay, and your ROC will be, okay, ROC will be z is less than some value and greater than some value. So this will be your region. Okay, z region. Okay, so it is arbitrary region. Okay, so if you consider the z plane, okay, so maybe the R1 R1 may be one value, okay, one value, okay, and R2 may be one value, okay, we don't know, arbitrary value. So your z will be within this period, okay. So this is example I just take. So these are arbitrary value, okay. So I just take some simple real value, but we can't say this R1 and R2 are real. They can be also complex, okay. So I just take the arbitrary value. So that, so this is that mean, okay. Are you okay with this definition? Are you okay with this statement? This is some value, this is some value, and this will be your region. Okay. Okay, I think all of are okay. I got the feedback from one or two students. I don't know what happened to others, okay? If you are not clear with this, please ask. This is this is just I mentioned, just we take a arbitrary region for Z, okay? So Z will be, so the ROC will be some kind of region, okay? Like this, okay? So this is the upper limit for the region, and this will be the upper limit for the region, and this will be the lower limit for the region. Okay. So I hope this is okay. Okay. Now we take the inverse. Now we take the inverse x minus n. Okay. So if I get the inverse, okay, so my Z will be Z here, the Z will be, all Z will be replaced by Z minus 1. Okay, I think this is clear, no? This is also okay, because this Z, okay, so here Z can be replaced by Z minus 1. Okay, and it is said that, okay, and it is said that, see here, okay, and it is said that Z will be now 1 by R1, it is greater than 1 by R1, and also greater than 1 by R2, less than 1 by R2. Z is greater than 1 by R1 and Z is less than 1 by R2. So what is he take? He take the reciprocal, no? He take the reciprocal of these limits. Okay, very simple. Okay, now I move to my, we move to our question. Okay, so we have u n plus 1. Okay, so what is n plus 1? It is, we have Z 1 by Z minus 1. So this will be our n plus 1. Okay, because we have to multiply it by Z only. Okay, okay, and ROC will be, okay, so the first ROC will be Z is greater than 1. Okay, and in time shifted it is said that, okay, in time shifting it is said that if this k is less than 0, okay, this Z is equal to infinity will not be in the ROC. Okay. So we can see that in our first, in our original ROC, we have the Z. Z is equal to infinity. Okay. But here you can see that k is equal to, k is less than 0. K is equal to 1 minus 1. That means less than 0. Okay. So the Z is equal to infinity will not be there. Okay. So Z is equal to infinity is not there. Okay. Okay, so now we will move to our time reversal. Okay, so here time reversal will be minus u n plus 1. Okay, okay, and okay, and this will be so here when it is minus, all this z will be minus 1. Okay, so here this z will be minus 1, so we will have z minus 1. Okay, and this also will be minus 1. Okay, so here you can see that this will be 1 by z. You can say that 1 by z. So if it is 1 by z, it should be 1 by z minus 1. 1 by z minus 1 means z. Okay, so z minus 1 will become z. Okay. Okay, so this is our time reverse signal. Okay, now the ROC will be reciprocal of this. Okay, so you can see that the upper limit, it is said that Z is greater than 1. Here, this one. Okay, here for this original one, the normal without time reversal, the Z will be less than 1. Okay, z will be less than 1. Yeah, okay, I have done a mistake, so I have to get the 1 by z. No, so 1, so if I get 1 by 1, it is not change. Okay, it will not change. I think that is the problem. Okay, so it will be z. Okay, so here z is less than 1, that is okay. Okay, so this is okay. I think, is this okay? So here I think I have done I have done a mistake. Okay, here this sign will not change, it will be here like this. Okay, I'm sorry. Okay, so it will be this one. Okay, so z will be less than 1, it is not changing. Okay, okay, now but this, what happened to this z is infinity. Okay, so that is not in ROC. Okay, that is not in ROC. Okay, but to get it here, we have to get the 1 by z, no, 1 by infinity. Okay, so that is 0, and that here the z is equal to 0 is not in ROC. Okay, it's not in ROC. Here it is z is infinity is not in ROC. Okay, but this z will be but this infinity will be 0 if we get the 1 by z. Okay, so this 0 is not in ROC. Okay, so this will be the ROC for the time reverse signal. Okay, okay, okay. Now I think we have evaluate. So it is not take much time. Okay, to do this evaluation. So if I get the Fourier, if I get the Z transform, if I get the Z transform of u minus n minus 1, okay, it will be z minus 1 by z, okay, and ROC will be 1 is greater than z, and z is equal to 0 is not in ROC. It's not in ROC. Okay, so this will be your Z transform, and this will be your ROC. Okay, this will be your ROC. Okay, correct. Now we move to the next one. Okay, so we have another function. No, so we have this one. Okay, I think this one also you can get. Okay, what is the property you can use to get this one? What is the property? I think here that property is also here. What is that one? What is the property? Yes, you can use the scaling. Z scaling property. Okay, that is Z scaling property. Okay, not the time scaling. The scaling is done in Z domain. Okay. Okay, so you can use this one. Okay, this one, this property. You can use this property. Okay. So so you have un, okay, that is 1 by 1 minus z minus 1. Okay, so ROC will be greater than 1. Okay, so here instead of un you have a n un. Okay, here it is half n un. Okay, half n un. Okay, and this z also will be scaling by half. Okay, so here you have 1 minus half z minus 1. Okay, so instead of your z minus 1 you have to put half here. Sorry, so instead of this z you have to put half z. Okay, so it will be become like this, 1 minus, instead of this z you have to put half z. Okay, and it will be minus 1. Okay, total will be minus 1. Okay, correct. Okay, so this will be your answer, no? Is it okay? This z we have to put half onto this z, no? So it will be half z minus 1. Correct. So a minus 1, no? A minus 1 z. Okay, so we have to use a minus 1 z minus 1. Correct. A minus 1 z minus 1. Okay, so yes, a z minus 1. Thank you. Okay, a minus 1 z minus 1, no? A minus 1 z minus 1. We have to use a minus 1 z minus 1. Yeah. So here it is a n. Okay, so here you have half un. Okay, so instead so un you have 1 by 1 minus z minus 1. Okay, so if you have half un, instead of this half you have to use for this z a minus 1, that is half minus 1 z minus 1. Correct. So this will be the answer. Okay, yeah, half, yeah, maybe. I can't, it is not clear actually, but I think it is okay. The answer is okay, no? Yeah. Okay, so answer should be, okay, so answer should be so if I get half n un, okay, so I have 1 minus, instead of this z I have to use half minus 1 z then minus 1. Correct. Okay, so if I simplify it I will get 1 minus, so here half minus 1, half minus 1, so you will get half, so here z you will get z minus 1. So this will be the answer, no? Okay, okay. So the ROC will be, so you can say that ROC will be, the lower limit and upper limit will be multiplied by this, multiplied by the magnitude of this value. Okay, so here, okay, so here we know that z is less than 1, z is greater than 1, that is for un, and for this ROC will be z is greater than half. Okay, so this will be the ROC. Okay, are you okay with this? Are you okay with this? So this will be my z transform and this will be my ROC. Yes, I think the ROC also clear, no? Yeah, maybe you still you have some doubts when finding the ROC. Okay, but don't worry too much. Okay, try to understand the concept. Okay, try to understand the concept. Then it will be easy. Okay, it will be easy because all we have to use very straightforward method. Okay, to find all these things. We have a method. Okay, we have a method. Okay. Okay. So okay, now we have find this term is a transform and this term is a transform. Okay, so both we have find. Then by adding them, you can simply find the composite signal is a transform. Okay, and the ROC will be the common for both. Okay, so I can simply add them together. Okay, so I can simply add this one. Okay, simply add this one. Okay, so this one and this one. Okay, so I can simply add this one. So that will be our XZ. Okay, that will be our XZ. Okay, so please add them together. So that will be our XZ. Okay, and ROC will be common. Okay, so here ROC will be greater than half. Okay, so greater than the half circle, that means here. Okay, and for the first one, ROC will be greater than 1, no? Greater than 1 except 0. This 0 is not there. Okay, so here ROC is greater than 1. Okay, so common ROC will be here, no, greater than 1 except 0. Okay, so this will be the common area, no? So that ROC will be, the common ROC will be, the final ROC will be Z greater than 1. Z is not equal to 0. Okay, anyway, the Z is not actually in this ROC. Okay, so you no need to mention this one specifically. Okay, it is already there. Okay, because if Z is greater than 1, Z is not Z is not in 0. No? That is very clear. Okay. Okay. So this will be the XZ and this will be the ROC. Okay. So I hope it is clear. Okay. Now I think very easy. Okay. Now I think it is very easy. You have to determine the XZ. Okay. So what you have to do? Okay. So you have to do. You have to divide. No. Okay. So you have to find the XZ. You can divide YZ by XZ. Okay. So YZ is already given. Okay. So that is this one half Z minus 1, 1 minus Z minus 1, 1 plus Z minus 1. Okay. So we will try to evaluate this one. Okay. So Z will be YZ divided by XZ. Okay. So what is YZ? YZ is half Z minus 1, 1 minus half Z minus 1 plus 1 Z minus 1. No. Half Z minus 1, 1 minus half Z minus 1. And this is 1 plus something, no? 1 plus Z minus 1. Correct? So this will be Z minus 1. Okay. So you have to find the XZ. Can someone tell me what is the XZ value? You can someone write this and simplify this? Okay. So what is this half UN will be 1 divided by 1 minus half z minus 1 plus what is our u minus n? This one, no, z minus 1, 1 minus z. Z minus 1, 1 minus z. Okay, correct? Correct, no? So you have to solve this one. Okay, you have to get the common denominator. Okay, common denominator. So here it will go to upside. Okay, so here you will have 1 by half z minus 1 and 1 minus z. Okay, so as the this is denominator, no? This is denominator. As the denominator, you will get 1 minus half. So here you will get plus z minus 1 plus half z minus 2. Correct? Okay. 1 minus z plus z minus 1 half z minus square. Okay. Okay. So you can write it here. So you get minus half when all these. Okay. So am I doing any mistake here? Minus half, is it? Yeah. Here you means it is minus, no? Yeah. 1 minus z plus z minus 1 minus half half z minus 2, no? Is this okay? Okay, but I think there is a problem. Okay, I think we have a problem with the simplification because we didn't simplify. We can't simplify this. No, this one we can simplify. Okay, this one we can simplify, but this one. So here we get some value. Okay, sometimes you can get the factor. You can factorize this maybe. Okay. I'm not sure. Okay, maybe you can factorize this and maybe you can find the solution. Okay, I'm not sure. Okay, anyway, I think this should be able to simplify. Okay, otherwise it is very hard to do this analysis. Okay, anyway, you can find the HZ. Okay, likewise you can find the HZ. Okay, so I think we have done some mistake anyway. Okay. So please go through that question and try to do by yourself. Okay, so I will also try. Okay, then if I found it, I will let you know. Okay, anyway, you can find the HZ. Okay, you can find this HZ, and to determine the ROC. Okay, determine the ROC. I think you can't use the yeah, you can use the property. Okay, you can use the property. There is a convolution property. Okay, for this convolution. Okay, so ROC will be this one, no, this one. That means the common ROC. Okay, so the common ROC will be, okay, so you have to find the ROC this one also. Okay, you have already find the ROC in XZ. Okay, that is Z is greater than 1. Okay, now you have to find the ROC for this one also. How to find the ROC for this YZ? Okay, How to find? So here ROC will not be infinity or 0, no? Because if you add 0 here, okay, 0 here, so you will get 1 by 0, 1 by 0, 1 by 0. Okay, that means you will get infinity by infinity. That is not defined. Okay, so Z is equal to infinity is not there. Okay, Z is equal to infinity is not there. Z is equal to 0 is not there. If you put the infinity here, you have 1 by infinity, 1 by infinity, 1 by infinity. So you will have 0 divided by 0. So 0 divided by 0 is also not defined. No? So Z is equal to infinity and Z is equal to 0 will not be in ROC. Okay. So this will not be in ROC. Okay. These are not will be in ROC. Okay. Correct. Okay. Uh, so here the Z is greater than 1 and Z. So here all ROC for YZ, all Z plane you can get except 0 and infinity. Okay. So here you can get Z is greater than 1 including infinity. Okay. Including infinity. So here for the resultant one, you can get you can set that HZ. Okay. So you can find the HZ here. No need to much simplify. Okay. No need to simplify. You can put it as you get. Okay, no need to simplify. Okay, so you can find the HZ ROC. You can find the HZ. Okay, we have already find. Okay, it is there is a problem with the simplification. Okay, so if you can't simplify it further, it is okay. Okay, you can put it like that. Okay, I think no need the simplification version. No need for the other one also. Okay, so maybe it is not simplified up to some very simple level. Okay, so that is the level we can simplify it maximally. Okay, maybe. Okay, and here you can define the ROC. So ROC will be Z greater than 1, but Z is not equal to infinity. So this will be the ROC. Are you clear with this ROC? Are you clear with this? I think if you are clear with this, you are okay with this one also. So here you are asking the ROC for YZ. So what is the answer here? All Z plane. Okay, all Z plane except Z is equal to 0 and Z is equal to infinity. Okay, so if you yeah, if you add any value, you will get the value, no? Okay, if you have any value, any other value, you will get the value here. Okay, all Z plane except Z is 0 and Z is equal to infinity. Is this okay? Is this okay? Yes. Okay. I don't know. I got the feedback from one or two student only still. Okay. So what about others actually? Are all clear with this? Okay. So here we have a set. We are given a set transform. Okay. Now for the ROC, we have to find in in for what Z value we can get the finite value. The YZ should be finite for Z value. So that will be the ROC. No? ROC will be the Z value that will give you the finite value for this YZ. Okay. Okay. So here you can sum value, here you can sum value. Okay. And so by applying 0 and infinity, okay, you can, and other one or two arbitrary value here, you can guess this. Okay, this will be my ROC like that. Okay. Okay, so determine yn. So how to determine yn? Okay. Okay, so can anyone tell me how to determine yn? How to determine yn? You have to find the inverse transform. What is the method? What is the method? Yeah, you have to find the inverse transform. So what is the method? In which method you have to find the inverse transform? Yeah, inverse is a transform. What method we have? So there is a standard one, contour integration. Normally we are not using that, and we have found another two methods now: power series expansion and here's partial fraction. Okay, you have to do the partial fraction method. Okay, so I think this one maybe we can go in a standard way, standard partial fraction way. Okay, because here you have yz is equal half z minus 1, 1 minus half z minus 1, 1 plus z minus 1, no? Yeah, okay. Uh, so you can do like this, okay? Mm, so here you can have 1 by z, okay? 1 by z half, okay? 1 by z half, and here you have 1 by 1 by 2z, okay? 1 by 1z, okay? So this will be your this will so after simplify you will get this one. So here I get down, okay? So I have 1 half z plus 1 by z, okay? So if I multiply both in z, I will have half. So here I have z minus half, okay? Here I have z plus 1, correct? Z minus half, z plus 1. Is it okay? Are you okay with this? I just simply do some simplification. Okay, I think if I think I'm not doing any mistake here. Okay, so I think here you can use that partial fraction method. You can get a z minus half plus b z minus 1 like this. Okay, so you can get like this. Okay, and you have to get the this one plus z minus half is equal to 1, correct? Okay, is this okay? Okay, I hope it is okay now. Okay, so we can get z is equal to half. If I consider z is equal to half, so this part will cancel. So I will have a is equal to, so this is 1 by z, 1 by 2, so 3 by 2, so I get 2 by 3, correct? This will be my a. Maybe I'm so you can check whether I'm doing any numerical mistake. Okay, so this is this should be half. Okay, so if I get z is equal to half, this should be half, and this part will be cancelled. Okay, so half plus 1 means 3 by 2, So A is equal to 2 by 3. Okay, correct, no? Okay. So if I consider Z is equal to -1, okay. So this will be 0, and you will have B is equal to, so here 1 minus, so it should be -1. Okay, so here -1. So -3 by 2. So here you will get -2 by 3. Okay. So this will be B. Okay, correct. Is this okay? Can someone tell me these are okay? Can can you do the partial fraction from here? Okay, use here. Okay, use this one and try to simplify this up to this level. Okay, because we need the positive powers. Okay, need to multiply right side. I have already multiplied, no? Right side means, you means no need, no? Because here you get A, okay, A is at half, okay, plus B is at +1, okay. So we have half, yeah, we have to get half here, okay. Half divided by 1 minus 1 to Z, 1 plus 1 Z, okay. So if I get the common denominator, this one and this one will cancel out, denominator will cancel out, and we will have numerator, no? So numerator will be A Z +1 plus B Z minus half. So this will be half. Sorry. Okay, so this will be half. Yes, you're correct. Okay. So this will be half. So this will be half. Okay. So this will be A is equal to 1 by 3 and B is equal to -1 by 3, because this 2 and this 2 will cancel out. No, correct? Okay. So I think it is okay. No. Yeah, yeah. Uh, right side should be not Z, no? There is no Z. No Z here. Right side, no Z. Because Z we get here. Now Z. This Z I put here. Okay, so this term doesn't have Z value. If it is has Z value, again you have to do a different way to partial fraction. Actually, that is I couldn't remember. Yeah, yeah. Okay, thank you. Okay, I think it is okay, no? Okay. So why is that we have, okay, so maybe this kind of partial fraction you can do. Okay, so if you can't remember, if you can't remember, please refresh your mind. Okay. Okay, so this will be, A, that means 1 by 3 Z minus half plus B, that means -1 by 3 Z plus 1. Okay, so you have to find the Z transform of this one and this one. Okay, so uh, so so this one will be okay. So I think we have found this one. Okay, I think we also get this kind of one. No, Z is square by 1. Okay, so this will, and here we have -1 3 Z by 1. Okay, so I think we have already found this kind of one. Okay, what is that? Our first one, no? U minus this one. This one we have the same value, no? Z -1, 1 minus Z. Z -1, sorry, this one, no? So this one, z minus 1, 1 minus z, okay, z minus 1, 1 minus z. Sorry, here we have z plus 1, z square minus 1. Okay, so what is here? Here we have, okay, z 1 minus z square we get, no? Okay, so we have to 1 minus z square. So how to get that term? Sorry, so this is not z. Okay, I'm sorry. Okay, I think you have confused, no? So you can see that we have already partial fraction the yz. Okay, so yz we have 1 by 3. Okay, please forget these things. Okay, 1 by 3. Where is the one? 1 by 3. Yeah, 1 by 3. This is not z. Okay, this is z and this is not z. Okay, I just confused that. Okay, so this is z minus half. Okay, so this will be z minus half. Okay, this will be z minus half plus minus 1 by 3. Okay, and z will be z plus 1. Okay, so it will be z plus 1. Okay, okay, so if I simplify this further, okay, so you can get this 1 by 3 out. Okay, so this is z 1 by z. Okay, sorry. So if you divided all these z by z, you will get z minus 1, 1 minus 1 half z minus 1. Correct? This is okay now? Okay, okay. No issue. I will upload the session, okay? I will upload the session, no issue. You can go for the prayers. Okay, so here z minus 1, 1 by 1 z minus 1. Okay, so this is okay, no? This is okay. Okay, so here we have minus 1 by 3. Okay, 1 by 3. Okay, so this is okay, no? This is okay, and already we have found this one, this type of Z transform. Okay, and this will be 1 minus 3. Okay, 1 minus 3. It will be yeah, 1 by 1 plus z. Okay, 1 by 1 plus z. So you will get this kind of one. Okay, yeah, and also you can make this one. Okay, so here you have to find the z transform, no? Okay, so if you make this one like this, 1 1 minus z. Okay, so do you have any sense here? Do you have any sense here if I put like this? So I think this is okay, no? You can find the inverse transform here. Okay, so because we have already find this. Okay, so when we are finding un minus this one, so the same type of result we got, no? Z minus 1, 1 minus z. Okay, 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 so here z minus 1, 1 minus z, 1 minus z we get, okay. Okay, so 1 minus z we get. And if it is plus z here, okay, so I think you can understand what happened, okay. So here it is plus z and here also plus z, okay. So what happened here? What happened here? So there is a scaling factor also. There is a scaling factor also, okay. So I think you can find this one. Can you give a try? I think you can find the yn here, okay. Not yn, this function you can find, no issue, okay. Now how to find this one? If you write it in this way, okay, 1 minus z, okay. Okay, can you get a sense here? So you know that for un, you have 1 by 1 plus 1 minus z minus 1. Okay, so this will be the un. Okay, so if you get u minus n, this will be 1 minus z plus. Okay, so this will be un z plus. Okay, so this will be un. Okay, okay, and so what happened if you multiply this one? If you scale this by minus 1, so you will have minus 1 u minus n, then you will have 1 minus this z this plus here, z plus. Instead of this z plus, you have to insert minus 1 z, no, minus 1 z, correct. Minus 1 z, then this is plus, and you will get 1 plus z. Okay, so this is same, no? Okay, okay. So so for this will be your un. Okay, this will be your time domain signal for this series. This will be your time domain series, correct? Okay, and here you have minus half, minus by 3. So you have to divide, multiply by minus by 3. So minus cancel out. You will have u minus n by 3 for this term. Okay, so this term you have find. Okay, for this term you get u minus n by 3. Is this okay? Is this okay? And if have I done any mistake here? So anyway, this is the common method. Okay, this way you have to approach. You have to go to a solution. This is the normal way to go for a solution. Okay. So have I done any mistake here? I hope no, no. Is this okay? For this one, this is okay. Yes, I think I got only 1 or 2 students actually. That is, I am worrying. Okay. Again, what about other one? Okay. Okay. So in the same manner, can you try to find this one also? Can you try to find this one? You can use the same method. Okay. Just you have to do this 1 and plus, put this 1 and plus here and there. Then try to get a common result. That is the way you should do. For example, so this is like this, no? Okay. So here you have, okay, I will do this for you again. Okay. So if you can, I'm going to evaluate this one. Okay. So please look at this one actually, at least. Okay. So I'm going to evaluate this one. Okay. So we know that un is a transform. That is 1 minus z minus 1. Okay. So you know that here I have I have a z minus 1. So what to do for what to do? So here I have z minus 1. That means I have shifted this, no? I have shifted this by n by 1. Okay. So I will have, if I shifted this, I will have z minus 1, 1 minus z minus 1. Correct? This is okay, no? This is a time shifting property we use. Okay. Then we have a scale here. We have a scale here, half. Okay, we have a half scale here. Okay, so I use half n in this. Okay, so I have u n minus 1. Okay, so this also you should be n. Okay, minus 1 n. Okay, correct. Mistake here. This should be also minus by n. Okay, so here minus n. Okay, so here also minus 1 n is there, and like this. Okay, so this will be the, okay, so this is not the answer actually. Okay, so for this part, okay, for this part it will be minus n u minus n divided by 3, and this minus is there. Okay, so this will be the answer. Okay, for this term. Okay, correct, because I forgot this n. Okay, I forgot this n. Okay, so we have to put the n also here. That is the scaling. Okay, can you remember? So that will be the scaling. Okay, so that will be the scaling. See, this will be the scaling. Okay, an should be there. Okay, I'm sorry. So here, you have 1 minus z minus 1, un minus 1, z minus 1, 1 by z minus 1. So I have to put half n. Okay, n minus 1. Okay, so I have, so half n, all for the all z value I have to put that. Okay, not only here. Okay, so for this one also I have to put, because all z should be replaced by half z. Okay, so all z should be replaced by half z, no? Half minus z, no? Yeah, half minus 1 z. Okay, half minus 1 z. So here it is not a problem, because so for this case it is not a problem, because we use 1. No? So so 1 minus 1 is also 1. Okay, so here it is not a problem, because 1 minus 1 is also 1. Okay, so for this it is also okay, but here you have to put half minus 1 is it, no? Correct, half minus 1 is it, no? Check. Yeah, here an, you have to put a minus n. That means we are use half n, so we have to use half minus n z. Okay, so I have to put the for all the z value. Okay, so here z also I have to use. So here I have to use half minus 1 z minus 1, and here I have to use 1 yeah. This will be 2n, no? This will be 2n. Okay, I will tell you. Okay, so here if I put this one, so I will get half minus n minus 1 half minus 1 z minus 1. Okay, no, yeah, that is okay. So here I will get, if I simplify this one, I will get half minus into minus 1. I have a half. Okay, so here I have z minus 1, and here I have 1 minus half minus 1 minus 1. I have half here. Here z minus 1, I have z minus 1. Okay, so what is I have? This part I got, no? Okay, this is I got. Okay, so this is I got. This I got. Okay. This one. Okay, so already we got this one. Okay, so what we have here? Okay, so what is we have? Okay, we have half n u n minus 1. Okay, so this is the one. So we need only this part. So we have to get rid of this one. So you have to multiply by 2, and this side also you have to multiply it by 2. Then this part will cancel. So you will have this part only. Okay, so you can have it here. Okay, correct. So this will be okay when you when you when you uh, when you convert it to a time domain, it will be this 1 by 3 is there. Okay, and you have half, so 2 1 by half n. Okay, so you can divided this one. Okay, so you have n minus 1 here. Okay, so these two can cancel out. Here you have 2n, so you here no no no. Oh no, it is okay, no? So you have n minus 1 here, because here 2n 1, so you have 2 here. Okay, so you have 2 half n. Half n means here I can write like this, 1 n half n. Okay, so here 2n minus 1 and 1n, so 1n is again 1, no? There is no change. Okay, so I can write this as half n minus 1 u n minus 1. Okay, so this is my this part. Okay, so if you add this one and this one together, you can find the yn, no? So yn is this one plus this one. Okay, is it clear? Is it clear? So if anyone has problem, you can ask. Okay, then I can at least I can do this again. I can do this recording again. Okay, so here I am doing some mistake, and you also with you also maybe with confuse those things. Okay, so if you said that this is not clear, uh, you have to study this. Okay, you can feedback. Okay, so my advice is please go through this lecture again. Okay, so here I have done some mistake, actually some numerical mistake. So sometimes if students are not touch with this, that will make confuse him more. Okay, so you can't understand it anymore. Okay, so you can do like this. Okay, first you can go through this lecture and try to understand this. Okay, again you can go through this lecture and try to understand this. If you can't, you can ask your friend. Okay, if it is not possible, you can ask me. Okay, then I can re-record this one without this method. Now I have done this now, so I can avoid that mistake. Okay, normally actually when I doing the questions, I am not calculating it first. Okay, I am just doing the calculation at the class. Okay, that is why sometime I stuck. Okay, stuck. uh, so you can do like that. Okay, so I hope this is okay. Okay, I think it is already, the time has passed, but we have to do some questions, otherwise it is not good. Okay, okay, so now we have done this one. Okay, we have done this one also. I hope it is okay. Okay, so how we how we perform this? First we get the partial fraction. Okay, so based on the partial fraction, we try to so we get some terms like this. Okay, with z minus term, z plus term, so on. Okay, so you simply you can try it. So this kind of expression you can get from un. Okay, so you can give a try to change this un by adding some properties. and try to get this Z value. Okay, so that way you can try. Okay, okay, now I think this one also not much difficult. Okay, uh, so here for y. Okay, I think this one and this one not this is another part and this one is totally different. Okay, because the yn will not be like that. No, yn will not be like that. Okay, so here you are given the yn. Okay, so you are given the yn as half n xn. Okay, half n xn. Okay, and you are given the xn also. So I think you can find this one very easily. How to find? You have already find the xn. Okay, you have already find the xn, and here you have to multiply it by half n. Okay, you have to multiply it by half n. That means again you have to do the time scaling. Not time scaling, z scaling for xn again. So you have already find the xn. Okay, we have already find the xn. We have already find this one xn. Okay, so for xn we get this kind of one. So for xn we get that this part, and this part. No, this part. Okay, we have to add this part and this part. Then you can get the xz. So again you have to scale them. Okay, by half n. So instead of result, you can simply apply half minus 1. Okay, so you have to get half in here. Okay, so here you have some expression with z. Okay, so for every z, you have to substitute half z, half minus 1 z this time. Instead of this z, you have to apply this one. Okay, then you can get the answer for this one also. Okay, and I think you can find the pole zero plot. Okay, actually that is depend on the mathematics. No, it is not depend on the set transform knowledge. That is mainly depend on the mathematics knowledge. Okay, can you try this by yourself? Okay, please try this by yourself, and I think part 2 also you can try by yourself. Okay, part 2 also I think this one I didn't mention here. Okay, this system is stable or not. I think I don't do it. Okay, actually it is very simple. Okay, so can you remember that if you have done S transform, using S transform, we can express a system is stable or not by looking at the poles and zero. Okay, so in S domain I think all poles should be in right hand side. Right hand side mean this one, no? Okay, as I can remember. If the poles are here, okay, you can see, you can say that your system is stable. Okay, but in Z domain, okay, Z domain, the poles should be inside the unit circle. Okay, so in Z plane, if you write the Z, if you write if you draw a unit circle, okay, all poles should be inside the unit circle. Okay, then the system is stable. If any point, if any pole is here, okay, outside the unit circle, we can say that system is not stable. Okay, so this one also I think you can do by yourself. Okay, so you can find the Z transform here. Okay, I will do this and I will record and I will upload this. Okay. Meanwhile, you can try by yourself. Okay. So try to, yeah, I will upload. Okay. I will upload, sure. Okay. So I will upload this two question and I also upload the recording session. Meanwhile, you can try this. Okay. So you can try this one. Okay. Then you can find the impulse response chain. Okay. So you have, here I think you can directly find the impulse response. Okay. So here you have to get the Z trans, inverse Z transform. Okay. So try a way to get this. Okay. I think you can use, you can't, the partial fraction method you no need to use. You can simply get this. Okay. So how to get this? You can write this as 1 by 1 Z3, 3 by 4 Z minus 1 minus Z minus 1, 1 plus 3 by 4 Z minus 1. No? Okay. So simply you can write this way. So you can write that HZ as 1 by whatever the terms. Okay. It is like this. No. 1 by, so 1 by 3 by 4 Z minus 1. 1 by 3 by 4 Z minus 1 plus, plus minus Z minus 1 plus minus Z minus 1, 1 plus 3, 4 Z minus 1. So this way you can write. This way you can write. Okay. And I think you can find the sequence for using UN. You have to do, you have to look at these terms and you can scale in time shifting and time reversing, you can get the answer. Okay. So this one also is scaling and time shifting, you can get this one. This one also you can get by shifting and time scaling. This one also you can get by scaling only. You don't need to do a time shifting. So here you can do the scaling. You can get the answer from UN. And here you have to do time scaling and time shifting. Time shifting, yes, time shifting. Then I think you can also get the answer for this one. Okay. Likewise, you can find the chain. Try to do that. Okay, I will upload this. Okay. This one also. Okay. Okay, I think this one also you can do by yourself. Okay, so can you give a try? I will upload the session tomorrow, day after tomorrow. I will upload this recording session. Okay, I will do this first and then I can do this clearly. Okay, so I will do like that. Okay, so okay, so if you can give me another 10 minutes. Okay, I just give you very simple question. Okay, and this kind of question also can be come to your exam. Okay, so if I ask you to like this, okay, so here you have a system. Okay, so give me a 10 minutes. Okay, 20 minutes. Okay, so if anyone is here, if it is, if anyone have any work, you can leave. Okay, I will upload this one, no issue. Okay, so let's say that the HN for this will be 1 0 2 3 or something. Okay, so this is your HN. Okay, and you have input xn. Let's say that it is 1 1 1. Okay, so can you find the yn? Can you find the yn here?